Like why people care about the node security?
Yeah, so most people, when they get started with Kubernetes, don't really appreciate how difficult it is to secure your node, and why you even care to secure your node. Like, what does that
Why?
even mean? And so, uh, what we wanted to do was start off with like, why do you care? Like, why is this important? By showing how an unsecured cluster, makes it quite easy to be able to go from one process to another, right? So, how do you go from taking over, say, a poorly secured web application and then use that to move laterally into some other application that's running on the same system? Um, and so this is the third iteration. This is the second iteration where we were going with Gatekeeper. This was originally, in the first edition, written around pod security policies. But as pod
Okay.
security policies were deprecated and removed in 125, we replaced it with Gatekeeper. We decided to go with Gatekeeper because we had already covered OPA to talk about some of the use cases you just mentioned for admission controllers. Um, and so one of the things that you know I find as a common theme, especially when it comes to enterprise, is trying to do more with less and trying to reuse components and knowledge. So in this instance, even though OPA isn't the most Kubernetes Kubernetes native approach, and Gatekeeper goes a long way to making it more Kubernetes native. Um, the ability to say, okay, I'm going to write policies that can both run in Kubernetes and, for node security, plus the policies that you had described, but also when we get into Istio near the end of the book, we actually do a example of using OPA to write an authorization controller for Istio. And so being able to use that same policy language across multiple silos is, to me, a very enterprise-ish way to think of it. Even if it might not be the best approach, right? It gives you the ability to reuse that knowledge, and that kind of, center of excellence versus homogeny is kind of a constant struggle in the enterprise world. Um, so that was the thinking as to why we wanted to approach that way. So we start off with, like, you've got the container breakout where, we start with first thing we start off is difference between a VM and a process container, right? A VM is a VM, right? Everything's isolated. A container is just a process. It uses some trickery in the kernel to give it a little bit of isolation, but you've got to do some work there to make sure that these processes can't interact with each other and you can't break out. And so, to show this, I like saying, just SSH into the node and do a PS, and you're going to see your container processes are running inside of your node, right? You don't have to be running, accessing the Kubernetes API to see these processes. So we kind of show that off a bit. And then we show a cool little container breakout that Duffy Cooley, field CTO over at Isovalent, had tweeted out, and it was just like, oh, okay, boom, you're hey, look, I'm able to, from inside of the container, put a file on the node file system, right? That's as simple of a container breakout as there is to, kind of wrap my head around and to show how that works. Um, and it's fun to be able to
So
say to our readers, hey,
one as
you hacked your node.
so one oh, good to can you hear me?
Yeah.
Yep. Yep.
I thought it was a phone call came in and I didn't hear for a second. What I was going to say was this aspect, right? That um, the I think misconception or people assumptions, right? A lot of folks I know that at least I work for a vendor and we offer Kubernetes, But the thing is, out of the box, Kubernetes allows you to do these two things, right? It allows you to create a pod, and the pod has the configuration of that running on that process. So in this case, we see two things, right? We see the host PID equals true, and then privilege equals true. And the misconception of someone may have is, well, imagine if you get Kubernetes from my cloud provider and those things are not allowed. People actually want that as a default. But at the same time, Kubernetes is open source, and the default in Kubernetes is like open by default. Like you should be able to run any software. And to me, I think is a debate that is one of the aspects that when we talk to folks that coming into Kubernetes in 2024, right? They say like, well, every blog post says like I have to like disallow this for the most part because I'm going to run software that is written in 2024 and it was built in 2024. So who's going to run software that needs host PID or privilege? Like that's not needed. But I think it's a problem that I see in our, at least in our industry with Kubernetes, is because, and I just have a theory, it's because when Kubernetes was created 10 years ago, the main purpose was to move legacy software, right? That was written, that it needed root, that it needed access to slash dev, that it needed access to processes for whatever reason. And the easiest way to move it into a Kubernetes or container world, it was like, let's make it open because that way any app can be ported to Kubernetes. And that's not the same as 2024, right? There's some legacy systems that need to be run, but I think at some point we need to flip the defaults. That's just my opinion of like, for people that want to run as legacy software and the need for host PID and true and like all these things, like they have to go to the extra mile, look for your book, right? Read this chapter, understand what that means, and like, oh, okay. So for this one app, in one container, in one namespace, in one cluster, then privilege equals true, right? Because we cannot change the software or the Fortran code is lost. We only have the binary, right? Um, so and then go back. So this is a debate I'm having, at least for also in our company. Like, well, if we change the defaults, then people have the assumptions that this thing is open. So what do you think around that of like secure by default, or like sometimes we call it like what is it called, the term zero trust? Is that
No,
related to zero trust? No, it's not the same.
zero trust is totally different.
Yeah.
You know, to your original point, you know, I think it was also, you know, we spent decades getting out of the habit when we stood up servers of running processes as root, right? Like everything got its own user and we got used to that. And then when Docker came around, we kind of threw all that out the window. Like, yeah, screw it, everything is root. You know, and when Kubernetes got started, because it was so deep into Docker, it was fighting that momentum that Docker container builders, and I don't think it's Docker's fault. It's just the way that the industry built around it was everything is root, you know, and there was a lot of issues with that. And then even something as simple like, you know, I don't know if this is still the case, but like once upon a time, most cloud vendors with their managed repos or their managed clusters, when you mounted a volume, right, like you auto provisioned a volume, it was root. And so if you had you know, if you're doing it the right way and, you know, you don't want your process to run as root, and so you need to set a UID on that volume. You would have like an init container that would chown the volume to get it to the right permission, so that way you could actually write to it. And that init container had to be privileged, so that was less privilege. So that's good, but that's still privilege. So I think that like a lot of things in the Kubernetes world, they started off, and I think this was a very smart approach because it got adoption ahead of,
Adoption. Yep.
you know, anything else, was let's make it good enough and then we can always lock it down. And that's been the approach. I think it was a very smart approach. And I think that it's worked out quite well. And when there has been pain, like moving from static service accounts to service accounts with expiration and token projection, there's pain. We go through it. So I do think it was a good approach, but it has led to quite a bit of confusion. I think we will get to a point in the not too distant future where some of the things that we assume are, the way it probably should be, are in fact false. And I think we're getting used to working in that kind of space.
Yeah, and I'm bringing up something here, like, and that's what I wanted to highlight, at least for this, was that for people's mindset of like, what is Gatekeeper doing here or Kubernetes doing here is preventing a certain configuration on the pod spec at the end of the day, like, to make it very simple, right? So the pod spec allows, for the most part, to be put any configuration that you want, right? You can run as root, you can ask for capabilities, you can escalate privilege, right? Elevate the privileges, but at the end of the day, the answer was like, well, Kubernetes doesn't have that by default. You have to run something. The API server will call you and then you validate. Like, we're not going to handle it for now, right? But in the recent time in Kubernetes, we in upstream introduce something along those lines, right? The validation and mission policy. So I think that this is a step on that direction of Kubernetes, of like, hey, instead of giving you a webhook that we call, like, you mess with the pod spec. If you want to delete things, or you say you're not going to allow it, to say, maybe it's going to be part of the Kube API server, that the ability for you to declare some of those policies in. Have you seen into this, and what do you think about this approach of using? I think they use Cell, for example, just a language, a common expression language, to define this type of policy. Is that this is the right direction, not the right direction, or what's missing for the next year?
I mean, and we actually cover validating admission controllers at the end of this chapter as another option outside of Gatekeeper. So in a lot of ways, validating admission controller was a response to the issues with pod security policies. Pod security policies were very complex, very easy to get wrong, a total pain in the butt to debug. I mean, pod security policies tried to figure out, based on identity of the creator,
Service account, right?
Not service account, no, not the identity of the pod, but the identity of the creator of the pod.
The requester of,
yeah. The requester, exactly. So can I, as Mark, create a pod with privilege? That's what pod security policies want to figure out. And that is an extraordinarily hard thing to do in Kubernetes, because I, as Mark, don't create pods, right? I create deployments, which create replica sets, which create pods. So the identity never makes it down to the pod level, which was one area that was an issue. Another area that was an issue was it was mapped very closely to Linux and Windows.
You mentioned that in the book. Yep.
Yeah, Windows nodes are a thing, and so PSPs didn't map with that. And so this weird, like, trying to figure out who did it plus who's it running as, that intersection. It tried to figure out what the best policy was. And so that a lot of that nuance made it very difficult to debug. And so validating admission controller said, you know what, we're just going to make this super simple. We're going to try and cover an 80-20 that says if you need privilege, you need to throw a label onto your onto your namespace. And because namespaces in Kubernetes are your security boundary, anything in that namespace can have privilege.
You're talking about
Right?
PSA now, right? The
PSA. Yep.
doing it to a namespace. Yeah. So that'll be the
Um,
difference of like at the namespace level, right? So no service account. I don't care what's the service account of the pod. I don't care who's the requester. If a pod shall be created here, you have to follow certain policies, and they're predefined in namespaces. I don't think you go into deep in here because then you want to jump into Gatekeeper. But
well,
that's how it works.
yeah,
PSA.
it's at the namespace level. And so if you think about that, like from a conceptual standpoint, in theory, that makes a lot of sense because that's the security boundary in Kubernetes, right? Namespaces. But let's go back to the use case I just mentioned where you need to mount a volume and you need to
File
chown it,
system with
right?
the init container, but the main
With
container
any,
is running as Carlos, right? But that init container, it needs to
it might
ch root, right?
need to run as root to do a chown,
On.
right? But the problem is with validating admissions, you can't write that policy, right? Because it's inside of the namespace. So that's it. So I think it's a good starting point. If you're writing microservices that don't require, um, uh, uh, you know, uh, uh, don't require a lot of help and don't require a lot of local resources, it probably works really well. But if you're doing anything with storage, if you're doing anything where you have to have
Service,
some privilege, um,
service mesh, another one like that has a way of like doing the init container to change the networking,
yeah, I
IP
haven't
tables
actually
to reroute the
tried
ports.
it with that. Scott, you do a lot with Istio. Have you tried Istio with validating admissions?
We have not, because we haven't really had a need to. Um, and with the ambient mesh, we kind of can change that
Hmm.
whole model around.
Yep.
There was some problems on AWS trying to do it a couple of years ago because of the init container, right? And
Right.
that was more, kind of unique to that offering. It's not doesn't have a problem now, but
Yep.
it's interesting. Maybe I'll look at that just to test it.
Yeah. So I mean, it's a good starting point. It's a good way to be like secure by default, right? You have to turn it off. But even something as simple as like running ingress nginx, which
You have the
requires a
sample
little
here.
bit of
Yep.
privilege, right? To run as 443. Now, whole other rant on why in the year of our Lord 2024, it's going to be 2025 soon. Does any pod need to run on 443? But that's a different conversation. Um, so, I find it to be it's a good answer to pod security policies. It does not replace them though, and that's why something like Gatekeeper, Caverno becomes important. Um, and the big difference between pod security policies and really any of the admission-based approaches is the admission-based approaches are not done. They're not trying to figure out multiple worlds. It's a policy. You have to pass all the policies. And so that's one of the more difficult parts about doing it with Gatekeeper versus,
Okay.
you know,
So you cannot make it of one if one of the policies allow like think about like network policies, right? That is like you deny. But if there's one that is like I'm going to allow this piece, then you can go through. This is opposite, right? You have to have allow like not violations on any of the policies that is going through, right?
right. Well, and the other thing is, and this is, we spent a lot of time talking about this from a multi-tenancy perspective inside of this chapter. With pod security policies, you could define a blanket policy that says, thou shalt not have a privileged container. Excuse me. Then you could have sub-policies almost that say, okay, but in these circumstances, it's okay to have a privileged container. So you turn it off by default, and then you turn it on as necessary. You can't do that with Gatekeeper.
You cannot do that with Gatekeeper.
I don't think you can do it with Caverno either. So what you have to do is you have to say, okay, we're going to make sure that each namespace has policies associated with it. And we will have a blanket policy that says if your namespace does not have policies for it, we're not going to allow you to launch any pods in it.
I see.
So you've got to think about it from that kind of multi-layered approach in a way that you didn't have to do for pod security policy. So we cover that in this chapter as well. But the other thing that we do in this chapter that's really cool that is we talk about container design and how you should design your container. And we get into distroless and whether or not you should be using
at the beginning.
Distroless. Yeah. And
talk a little bit about distroless. Let me hear. Here it is.
I'm not a huge fan of distroless.
Why do you hate cats and dogs, Mark? Everybody likes distroless. It's cool,
everybody likes
right?
antivirus ones too, and it turns out that wasn't the best idea. So it's getting better,
but it has some aspects of it, right? Like maybe you don't like the implementation, but is the thing that we can agree is less files in that container that are not needed, the better. No,
I don't agree with that necessarily.
Okay.
So here's the part that I disagree with. There are two sides of it. One, the operations side. If there's a broken container, right? There's a broken pod, and you need to debug something. You need to get into that container to do it, right? And then you need tools. So classic example of firewall rules, right? Launch a container, I can't connect to something. I can't connect to a directory. I can't connect to a database,
the thing is,
whatever.
it's live container. You don't want to reboot it. You don't want to create a pod because that's what I want to debug, right? That's just to clarify.
And so I want to exec into that pod and run a curl command, right? Now, the security argument is if you have curl in there, then that makes it easier for an attacker to leverage against other tools. What if I told you I could run a curl command against a container without you having it there in the first place, without you even having a shell?
Yeah, you can use an SSL binary or something like that.
Yeah, exactly. I could copy it in to your scratch pad and do it from there. I don't need a shell to run those commands, right? So it's a false sense of security. So that's the first problem. But you're taking away the tools that operations needs to quickly debug something. So availability is part of the triad of security, right? Availability, confidentiality, and availability, and what's the I? I'm always forgetting the I. But availability is part of security. So if you can't keep the thing available because your operations teams can't figure out what's going on,
security problem,
right? So there's that. Now, to combat the operations side, there's this concept of the debug container, and we go through this in here.
Yeah, you have it in the sample. Yeah.
Where you can launch a container that attaches to the process. So in chapter 1, Scott does a really good job of talking about the differences between attach and exec in Docker, right? Same type of idea here. You can attach a container to a running process. Here's the kicker. You need to enable a level of privilege in order to make that work. So in order to have a secure container that you can now operationalize, you need to give it privilege. And I don't think we've done a really good job of figuring out the potential avenues that privilege can create. So
can you give that privilege without deleting the pod?
No.
Right. Then you lose your debug environment.
Exactly. So you have to launch the pod with this level of privilege. So I don't think we have a really great handle of those implications yet from a security standpoint. So this isn't the same thing as when you launch your server, you should have as few services as possible. That's totally cool, right? Like that I'm totally down with. But saying, oh, I've now created a more secure pod because it doesn't have a shell and it doesn't have, it doesn't have curl on it, is like, really? Like you've taken away your users' tools. You're saying, and the counter argument to this is usually, well, we have observability tools built in. That kind of sounds like antivirus to me. We've cured the disease by killing the patient by injecting this additional thing that now ops teams have to work with. I think it
So
worked
the
really
layer,
well
so the
in the
layer, so if I
microservices
allow,
world.
so if I don't leave, if I allow a little bit of like less not necessarily security, but allow to have curl and allow to debug in that aspect, then I think is what I'm now you open me the light about the next chapter, maybe at the kernel level, right? So you are allowed to do debugging and shell, but maybe I need to put something on the kernel, and I say kernel on purpose because it could be something like eBPF, Falco alarm. I know Falco doesn't prevent, but it's your alarm. But it could be eBPF something prevent, right? Or it could be something like the next chapter, which is using Linux tools to say you are allowed to SSH and run curl, but you're not allowed to read this file system or this file, or you're allowed to read a file, but you're not allowed to write the file, right?
Yep.
Is that
Yeah.
then that's why you should put the next chapter after this one? I'm just realizing that now.
Yep.
Scott?
Yeah, I think that would be the reason for that format. Probably, I'm going to be honest, probably a happy accident. I don't know if Mark and I actually said, should this go first or this should go first? But yeah, because it does extend on that. And that when we wrote the update, that was actually the first chapter I attacked. So I attacked Kube Armor first because I really am a big runtime security person. So when we get over to that, Carlos, like next week, right, we'll never cover that in
Yeah.
this kind of time. But I know one of your first questions just earlier was default by security or don't have it, right? From day one when we were designing what we did at work, we had OPA. Well, we had to, because going back then, even Nginx ingress controller didn't have a validating admission at all. So you could have ingresses hopping on top of each other, right?
Yep.
It was really a
Yep.
nightmare. So we needed that. I have to stop privilege, right? You don't want somebody execing into a container, like Mark said, cherooting the operating system from the host, for an example. And man, that's just bad from that point, right? They can just spin up a container themselves. Registries too, right? But yeah, this only does so much. And the distroless, I go both sides of that.
Yeah, in
Security
your
is one
industry,
thing.
in your industry of banking, what did you do in practice? How do you have all the alternatives of debugging, or you say, yeah, that it's better to have no debugging aspect of it than having debugging and then we run the risk? What's your take, at least in your area?
Good. It's a good question. It's a tough question, right? Because developers don't want to be controlled. Who can blame them, right? Let them do what they need. So we basically don't force a lot of that down. However, we had a bunch of tools, the ecosystem around this. So we mitigate a lot of problems that way. Might be runtime security. It's going to be, of course, Gatekeeper, Falco, even
Network
Falco.
also?
Yes,
What
yeah,
things you are
network.
allowed to do?
Yeah,
Network will be
Mike.
the first one, right? That everybody says, um, make the list. Yeah, allow this container to only talk to certain things, and that's it, right?
Yep.
You don't need more than that to debug, right?
So micro-segmentation, right, in that kind of a way. And that's one thing I do like to consider is when you create a new namespace, you should have a network policy that's just deny both, right? Start off with that, and then make people open it up. The problem is it's tough to do in brownfielding, right? You got a bunch of stuff running now. Try to enforce that is a challenge. even stuff like Gatekeeper and OPA, right, Mark, you mentioned particularly, I like calling this out, deployment replica set pod. The problem with policies, I don't say problem, it throws off developers to a point because you deploy something, kube control apply, whatever, and you don't see a pod, right? You're sitting there going, I don't get it. What's the problem? And they think there's a problem with the scheduler or there's something else. Well, the replica set's stopping that, right? So you got to describe the replica set. So if you don't understand how Kubernetes chains down these resources, it's actually one of the first things I would ask people in an interview. I said, please tell me you make a deployment, what 3 resources are created? And that's what I want to hear. And I'd have people ask me why. And I said, well, and I used the Gatekeeper example, right? Because you'll sit there spinning your wheels looking for a pod that's never going to happen because Gatekeeper blocked it.
Yeah, and debugging it. But back to the policies, like you say, like a developer, I agree with that. But going into the enterprise, then you can have a choice of saying developers, like you mentioned, they work and they don't see the pod running, and that will be a lower environment. And in the lower environment, we're going to have different policies than the prod. But also you can have another camp saying, no, that's trouble because that lower environment should match the production environment for them to have a secondary place where they can actually don't have to debug over there, but maybe debug over here. So what's your take in that? Because right, one thing is like a developer having access to a Kubernetes cluster in a lot of enterprises. Like this is the Kubernetes. That's why I'm bringing this use case, because the book is about enterprise.
Right. Mm-hmm.
A lot of enterprises, people is like, well, developer doesn't have access to a pod. Like they don't, right? They don't have access to Kubernetes. Why would they have access? They have access to Grafana, and only the metrics that they need. They have access to logs, so they go to Datadog. They have like some layer of platform abstraction on seeing what's happening in production. But what's your take between, and people will say, well, just dev, like open it up. But I've seen enterprises saying like, we already tried that and we had so much problems because things always work in dev and stage it. And when we're going to deploy a new app into prod, we always wasted a week because the delta. Is that true? Not true? I just relating my personal experience, but I want to hear from you.
No, I would agree because we're talking about just the containers at that point. What about maybe a cluster upgrade, right? You have to know everything should be in lockstep because you're just not getting an accurate test. I mean, on paper, I know where people would say that, right? Let's have dev open. Yeah, but one little setting changes it, and then you don't know what's going on. So we even treat our we call them non-prod. We don't call them dev because let's face it, cloud world, they're being used all the time. You're iterating like crazy. So we treat them as a tier 0 service even to say, okay, that's got to be running. So they are identical. Everything down the line. So DR and prod as well. We've changed over the years, right? Because as people get more mature into this entire ecosystem, you can start taking away exec. I mean, I agree with Mark, exec can be great, right? It can be, but you take away exec, you take away a lot of issues, potential security issues. Until then, you can do something like kubearmor, where you can still do exec and get certain things, but now we can limit other processes.
Yeah, oh, sorry, go ahead, Scott.
No, go ahead, Mark, I was done. Good.
So I think that there is a pendulum that we see with any kind of platform, and this predates Kubernetes, where the team that owns the platform at one end of the pendulum says, we're going to build this very locked down system that's very well engineered. And the people that use it then say that platform is the bottleneck. I am responsible for my application, my paycheck, my bonus. My boss is not the same boss as the person who built that platform. And so when I'm not in a position to be able to fix my application, I tell my boss in the blame storming session, it's their fault, right? Like I can't get in. And that happens enough times, the people who built this great platform start to say, screw it. We're just going to open it up for everybody. And the pendulum swings the other way and it gets super open. And I think that that's what we're seeing in the Kubernetes world, where we started off to the side, and I think a lot of it is the difference between microservices architecture and monoliths. Monoliths are a bigger thing in Kubernetes these days. And so, because monoliths tend to be more complex in the way that they're designed, and the way they're built, the way they're operated, and the enterprises that operate them are more complex, you need to provide your developers, and who are often a part of your ops team, right? Like, when I was doing a lot of work in the US federal government, we used to say the reason why they call it DevOps is they're not willing to pay for an ops team, right? The developers were the pagers. And the security was there, right? Like, you had to go through, your different security clearance levels and whatnot to be able to work on those systems. But your developers were ops, and I think in a lot of large companies, you're going to find, and a lot of large enterprises, you're going to find that same thing, where the people who write the software are also responsible for operating it. So this idea that there's this great wall between dev and ops, I think is a bit of a fallacy of the DevOps world and the platform engineering world. So the idea that you're going to have a lockdown dev, or excuse me, an open dev but a lockdown prod, to Scott's point, you got to have it the same, so that way you're working on it. But you also have to realize, what are the lines of reporting in those silos? And when the bad thing happens, where do the fingers get pointed? And I think that's where a lot of modern platform design falls down, is it makes really bad assumptions as to the way the silos are built. And I see Jack's got his hand up.
Jack, hey Jack, nice to see you.
Oh, hi. I wanted to wait till the end of the call before I raised my question. And if it's too complicated or too off topic, never mind.
No, go ahead.
I have my customers buying software solutions from multiple vendors, not employees of the company, not employees of the enterprise. And my customer's ops team is herding cats, getting the vendors' schedules all lined up so everything all lines up into a system that they can operate. And when something goes wrong, they are implementing their own best practices to permit non-employee vendor representatives who are trusted to bypass or they're given special roles to plug into the security policies. Is there a best practice across enterprises that covers that case? It sounds like your models are all assuming the devs are all employees of the enterprise.
No, not necessarily.
Okay.
I mean, so I've actually got a customer that we do something similar for, where we onboarded them into the system, and they're like, well, our vendor needs to have secure access.
Temporarily or permanent, Mark?
Temporary. And so Mark,
I'm sorry to interrupt you quickly, but I have to get on a 1 o'clock call. I just wanted to make sure. I want to thank everybody.
Yeah.
Thank
your question, by the way, is something we could talk about on the side. I deal with.
I'll be at the booth on Wednesday after next.
Oh, you
that'll
meet
be
me at
Mark.
Yeah.
I won't be there.
I'll stop by and say hello.
Okay. All right.
I wish I was. I don't. That's another touchy subject.
Okay, good.
Thanks,
Very good. Thank you.
So we ran into this exact issue where it was a public safety system, and the vendor, it was not unusual for the vendor to have to be able to log in and access it. And so they're like, well, can we just give them a temporary account? And I'm like, that's shared password. That's a bad idea.
Mm-hmm.
And the way we ended up doing it was that particular vendor had Azure AD. So I said, all right, we'll integrate with Azure AD, and we built a policy around it. And, we had to build specific policies that said, when this vendor logs in, the only thing they have access to is this one application. Right. And we tried to, our original proposal to them was that when the vendor logged in, somebody from, this was a county government that was responsible would have to approve their access to do it temporarily, and they're like, oh, we're not getting up in the middle of the night to do this. Like, we'll just let them allow in, like if they're coming from this vendor. I'm like, oh, okay, if that's what you want. And then they said, okay, we'll control the authorization at the application level. So I said, all right, so that takes it off
I
of
see.
me. That's no longer my problem. So it's not one size fit all, but yeah, I mean that's one of the corner cases as an example that a lot of the the reference architectures don't design around, and it's your corner cases where you're going to spend all your time and time is money, right? And resources are money. So yeah, and that's one of the reasons why we designed the book the way we did, was to say, look, we're not going to give you the architecture. Here are all the different tools and how they fit together, and have at it.
Okay. Thank you.
Thank you.
Thank you. We're out of time, but appreciate your time, Mark, and also Scott Drop, and everyone that joined today. I think it was a useful discussion because in terms of enterprise, there's a lot of I wanted to get your insights. The book is there, but Gatekeeper is one of the solutions actually used in production as other ones. The only thing that I hear feedback is about Rego, the language. But other than that, if you have someone, now you have LLMs, and then you have more software, and there's a lot of ecosystem tooling for that that can help with that. But yeah, I want to thank you, everyone. We'll continue next week, and I think then for the KubeCon week we'll make a pause, and then let's talk in KubeCon, Mark, to see if you want to continue with other chapters, or I can continue with Savvy with the other chapters. It's fantastic book. So we'll see you everyone next week.
Thanks, everyone. Bye.
Okay, bye-bye.
Yeah, bye.